For folks just joining in, welcome to the 5G Security Challenges panel. We're excited to have you. We're going to give just 1 or 2 minutes for people to figure out how to work the first session of this platform. So we'll get started in just about 2 minutes. But so for attendees, welcome. And while we're waiting for attendees to join in, if some attendee wouldn't mind just putting a quick message into the chat to say that you can see and hear us okay, that would be appreciated. Looks like we heard from Dave, so thank you. All right. Well, let's see. So let's go ahead and get started. We're really excited to have everybody on board. I think what we have is a fantastic set of panelists to talk about interesting challenges on security for 5G networks, which is definitely an interesting topic. Just a little bit about logistics. Right? So, I think this is the first time ACSAC is doing the purely virtual conference. So, we're all kind of learning this, but so far so good. There's a chat in Patchable. So the ACSAC preferred way to send chat messages is in the Patchable. I see one chat there from Dave Ballinson, and I see a few chats in the Zoom as well. I believe that only myself and the panelists can see the Zoom chats. So if you do post a chat, please post it in the Patchable via the website. Let me just briefly show you, just to make sure we're all on the same page. I will do a brief screen share here to see. Yep, here we are. Here's at least what my view looks like. Right? You should hopefully see something similar. And if you type your questions there, it'll be viewed by all panelists. So with that, we're excited to have you on board. It's a little bit strange for me not being able to look out and see the audience. So please do put stuff in the chat. Otherwise, we're kind of speaking into the void. And we've got a ton of great speakers, and we will continue on. So we'll make this a better, more interactive panel the more we can get in the chat. So with that, let me talk a little bit about the overall objectives, and then I'm going to give each panelist a little bit of time to kind of introduce their view of the topic. So there's been a lot of emphasis on 5G and 5G security in particular. What we've got happening here is a number of important changes. We see 5G from the perspective of my role at the U.S. Department of Defense, that we have an entire initiative on helping to accelerate 5G. This is becoming important in whether it's a military communication, whether it's our personal communications, or critical infrastructure. 5G is certainly emerging as a key topic, and security of 5G is going to be essential. So we're going to look at the security of 5G with the panel, and I'm going to start off. I'll do I'll quickly run by who we've got here on the panel. Fantastic set of folks. So Vincent Treatapon from DHS has been doing, has been leading a lot of the 5G work in all kinds of the government. Alex Princeton at NSF has been leading some of the initiatives there. Sumit Roy and myself are both relatively new at the Department of Defense, in particular the Office of the Undersecretary of Defense for Research and Engineering. We're part of the 5G initiative. Wayne Foll is at ARLIS at University of Maryland, has worked a lot on this area previously at DARPA, as well as many other places. And Ehab Al-Shaer is now at Carnegie Mellon, and is, as we all know, is a well-known name in the cybersecurity area. And so I think together we bring an interesting perspective. I'm going to kick it off by kind of getting out of the way and passing it first over to Vincent. And Vincent, do you want to say a little bit about sort of your view of 5G, and I'll hand it over to you.
Yeah,
Thanks.
great. Thanks, Dan. Well, appreciate the opportunity to be on the panel. So my name is Vincent Sertapan. I do work for Cisa. Some of my role and background, just to give you a sense of, because I have sort of multiple hats. First off is acting section chief for the Cyber Quality Service Management Office. So I look at mobile security services across the CISA and how we can use that to protect federal networks, or specifically civilian departments and agencies on the .gov. Additionally, I also am the 5G cybersecurity R&D lead, right, for CISA. So a lot of I'll talk about our CISA strategy and sort of our view and why we actually have a strategy. You look at the national strategy to secure 5G efforts. But in the other hat I actually have is the co-chair for DHS CISA, specifically for the Federal Mobility Group. It's an organization chartered, a community of practice chartered under the Fed CIO Council and the Federal CISO Council. We have about 45 departments and agencies, over 200 plus members. We work on everything from security, acquisition, 5G efforts, and then mission enablement, all around mobility, right? What are the common problems we have? How can we solve those problems, sharing best practices? So our view, or my view, I'll tell you, really is about in 5G from CISA's angle, is that great. It's a lot of great opportunity, right? You have enhanced mobile broadband, you have ultra reliable low latency communications, you have massive machine type communications, all of which can be applied to various use cases as you see people funding and operating. So we think it's great from an opportunity angle, even from the research side, but you got to think about what are the challenges, right? When you think about the implementation and the potential for vulnerabilities to be sort of inhibiting its secure deployment, there's a lot of concern there. Whether it can just give you some examples, such as attempts by threat actors to influence the design and architecture of 5G. Think about that. We also are concerned with things like the 5G supply chain due to either malicious or inadvertent introduction of vulnerabilities, to just 5G technology potentially increasing the attack surface for malicious actors by introducing new vulnerabilities. So there's a lot there, including competition concerns that we have, but notably that this is a great opportunity, but also a great challenge, right? And what I would say is that from our role, and you can look it up on cisa.gov/5G, you'll find we have a CISA 5G strategy, right? And our vision in this case is really with 5G connectivity that enhances national security, technological innovation, and economic opportunity. From a mission point of view, we're looking to lead 5G risk management efforts to promote the deployment and development of secure and resilient 5G infrastructure. And we have established, in this case, 5 strategic initiatives really surrounding 5G security and resiliency. So I don't want to go into too much detail for this type of audience. I will say from the research and development side, with the research community industry, we are in our 4th strategic initiative looking to encourage innovation in the 5G marketplace to foster trusted 5G networks, right? So on our types of things, we look at things like lab as a service, right? How can we establish end-to-end security architecture in 5G, whether it's based on the 3GPP release and release 15, and as that deployment comes out for the United States and others, we want to look at, well, if you try all those things and that works, that's wonderful. But what if you add additional, all the security capabilities that are on top of that? Is there still a gap, right? Understand that in the United States, when we talk about security enhancements in 5G, security in the United States with the carriers, as that's proprietary, we don't necessarily know what's under the hood. You'll find that security is optional, right? Look at the CISRIC report with the FCC, look at various aspects. Security in the United States is optional, right? So, but if we turned on everything in our tests, right, that'd be great. And we applied all the security appliances that every vendor or OEM wants to throw at it. Is there still a gap that exists, right? We don't know. Parts of the testing looks into that. So I do think, just to keep it short, that it's a great opportunity to discuss in this panel. Great speakers here. I will note that lot of opportunity, but a lot of risk. As we move to standalone, we move to more virtualization, all those, sort of traditional threat vectors. Now we have to be concerned with how are they purporting over to telecommunications for us, right? So really appreciate the opportunity, and I'll stop there.
All right, thanks a lot, Vincent. I think that's a great introduction, and I especially like that the notation that security is optional, and I would think that the ACSAC crowd in particular would agree with us that probably should not be the case. But we'll get more into that. Let me let our next panelist, Alex Svensson, talk a little bit about. Now, Alex has been leading a number of the 5G security initiatives at NSF, and so I'll pass it over to Alex to say a little bit about what's going on there.
Thank you so much. Can you hear me and can you see my slides, right? So just to make sure.
Yep, all looks good. Thank you.
Okay. Yeah, thank you so much, Dan, for inviting me. It's kind of a very interesting time to be in this area right now. So I will present a couple of thoughts that we had from the recent NSF workshop that we ran actually with Dan on trying to kind of create a roadmap for research for next G security. So at NSF, we typically don't want to focus on particular releases. We're just kind of trying to talk about fundamentals. So we talk about next gen wireless, but it's 5G and beyond. And we see it definitely as a game changer, kind of compared to traditional cellular networks that we have until now. And it's game changer because we transitioning from connecting people through cellular phones to connecting billions of IoT devices, right? So we kind of enable machine-to-machine communication, and the network is much bigger, right? So those devices are low cost, power constrained, software driven, right? And very, very simple in some sense, right? So, and this poses a lot of issues with securing them. We also have increasing reliance of society on this next gen infrastructure, right? We expect those networks to be highly reliable, and we expect some level of service assurance. Also, we see integration of other industries such as transportation, defense, safety, and industrial. Okay, so instead of running proprietary networks, we expect those industries to utilize much more of the slices of 5G. And also, we think that this will enable new applications such as AR, VR that are kind of very demanding in terms of bandwidth, for example, low latency. So all of those kind of creates opportunity to kind of to changing for a game changer in this area. So if you're looking on underlying technologies that make this next generation possible, we see integration on very, very diverse techniques, right? For example, transition to Massive MIMO. So we talk about physical layer security, right? So all of those techniques, they actually might introduce, as Vincent alluded to, an additional vector of attacks. We seeing transition to higher frequency, millimeter wave, the use of beamforming, softwareization, right? So we see a lot of stuff that are virtual, right? Which introduces additional challenges in terms of resilience, a lot of virtualization, network slicing, right? Again, how those slices affect each other, a lot of kind of ways to attack the network based on this architecture, microservices architecture, reliance on cloud and AI as well, right? So AI is kind of, people think it will play a major role in future 5G network, but again, it poses certain security issues and resilience issues as well. So again, it's a disruptor, right? So we have a lot of new players and stakeholders. It's kind of multiple technologies converging here, and we want to allow systems very flexible, for example, to transmit of different ranges of frequencies, but all of this is kind of from a security perspective poses a lot of challenges. Also, people think about next G is just not only connectivities, but also introducing a computational power, allowing applications, for example, to use compute power at edges and at cloud. We also can use 5G for control in industrial settings, use it for content delivery, and also for traditional role of connectivity. So again, as Vincent alluded to, the current focus in design of those networks, and we see it definitely in 5G and 6G and beyond, it's performance and functionality, right? So we want to have more bandwidth, we want to enable additional functionality, low latency. There are some security enhancement, but it's not really a focus of all those networks, right? And also, with integration of those different technologies, we see that complexity of the system grows a lot, right? And all of this really worries us in terms of security. And current approach is basically short-term approach to password security, and it's no guarantees of predictable behavior. And such behavior is basically, we cannot even capture it by specification of its components, so we cannot really predict how the system can behave. And this has a lot of application in terms of security and the resilience. So from NSF point of view, we're looking again more long-term. So we want to provide end-to-end security, right? So we wanted the solution works in integrated end-to-end fashion, and it includes securing individual components, but also integrating and composing those security functions, right? Because we have a lot of attacks vectors, for example, at physical layer, at cloud, at slices, right? How all this works together to deliver this end-to-end security. There is also opportunity for security community, right? So for example, we can have different slices, so we can offer security as a service. We can talk about tunable security because different applications might need different security guarantees, right? It's definitely, if you're running a defense application, we expect it to be more secure than just, for example, gaming application or something like this. We can also develop new paradigms from static to dynamic configuration in terms of security. So security can be highly adapted and can also be programmable. In the same way we built our network software defined, we can also extend this approach to security. So it's not just a static configuration that can be attacked, right, by more agile adversaries, or why defense cannot be also agile. And also, it's always a fundamental trade-off between security and efficiency, right? So we wanted security to be with minimum overhead in terms of performance. Okay, so challenges that we're posing. So first of all, as I mentioned, is the complexity of the system. It's very, very hard to protect a system that it's very complex and very spread out geographically, and also like from all kind of, including across all levels and layers, right? So we have a physical layer, core and cloud, and how to coordinate all those levels of security. And security that's prepared, for example, if you prepare a solution for just one layer, it might not work for this distributed edge cloud systems. And also there is a lot of opportunities here. For example, in physical layer, we can get a lot of information about specific devices and attacks, but how we can convey it to other security functions that can reside, for example, in core, on edge network, or on cloud. Okay, so again, we would like to see move from static to dynamic policies. We might need to live with that some of the element of the system we might not be able to secure, right? So as mentioned here, right, we might need to live with this, right, and kind of compensate for that and kind of adding security at other level. We also have an issue with standards, right? So they don't have right now complex kind of some formal representations of those standards. There's a lot of kind of uncertainty, right? How they defined, a lot of they kind of a little bit vague and written in a way that it's easy to penetrate. And maybe like there are some security issues in the standard, right? Some different players can kind of cause some intentionally or unintentionally some issues with the standards themselves. And also we need to think about how to kind of establish postures in virtual environment. And also it might be inherently decentralized for such a large system. So those are some of the thoughts, and kind of just go back to Dan. And it's kind of as a result of this workshop that we run together. Thank you.
Great. Thank you so much. I think a lot of interesting stuff that we want to kind of come back into there. You know, two things real quick, and then I'll pass it over to Sumit, right? So I think that idea of different security guarantees for different users is something that's viewed as highly relevant from my position, and I think would be echoed by some of the other panelists. And then a nice transition into Dr. Roy is, you you mentioned how this is 5G is really spanning all layers from the cloud to the physical layer, and Sumit, so you have a lot of expertise, especially at the physical layer as well as throughout the whole stack. What's your view of 5G security?
Hi, Dan. Thanks, and appreciate the invitation and the chance to contribute to the panel. So, following up on what Vincent and Alex said, I won't repeat many of the 5G relevant features that they brought up. But before I get into my view in response to your question, just a short brief about myself. So, as Dan mentioned, Dan and I are head two sort of thrusts within the 5G initiative in OUSD. So I'm the program lead for the Innovate Beyond 5G, and while Dan heads Operate Through. And what my program is essentially responsible for is in DoD, parlance, what's called 6.2, which is applied research, and hence my portfolio is really responsible in sort of one sentence, looking at what Alex says, said in his last slide. Usually, we think about performance efficiency. So sort of big PE, whether it's the gigabit throughputs that 5G is supposed to provide per user, peak rates, or the ultra low latencies, all of the KPIs or QoSs that we associate with 5G delivering for various use cases. So, my program is essentially focused on exploring technology and composing it, as many folks from an academic or small business perspective would realize that we are looking at technology. We need technology enhancements using the 5G standards as a guide. Okay, but having said that, and this panel is about security, and we all know, and again, referring back to the very valid point that Alex made, there's trade-offs. And very often, security is thought of as a patch on or afterthought. And there are inevitable trade-offs between achieving all of those, sort of what I call big PE, big performance efficiencies, and then, relegating security to be an afterthought. And I think, in response to the question, Dan, that you asked, what I would say is the following. First of all, as we progress through all the Gs, well, let's remember that, very often when this question of security is brought up, sort of publicly or to a broad audience, there's kind of a subtext or an expectation that, you either have security or none. So it's a all or nothing. And it's best to realize, again, that the systems that we are talking about is so complex that, security can only be understood as something stochastic, if predictable stochastic. And then, as most of us in academia that have been educated, it is dynamic. It's a game. So, it's really some sort of a stochastic game. So, if people accept that paradigm, there are, which could be a dismal paradigm, but I think it's a more accurate paradigm. There are always, vectors of improvement. So there are, 5G, 3GPP has a working group 3. And they've been active for many years. And, one can actually point to concrete improvements in 5G security vis-a-vis, say, 4G. So it's not that things don't change. Things change sometimes, in some vectors for the better and in other vectors for the worse. And, we have both living simultaneously. So let me just characterize it. Some of the things that have changed potentially for the better in 5G is encryption and authentication. So for example, 5G has made the security group has made an explicit effort to not have, so as you realize that, with the massive machine-to-machine, cases, we are moving away from the universal SIM paradigm to a more device ID-based paradigm. And 5G has made the security group has made an explicit effort not to have any permanent device ID over the air that is unencrypted. So, authentication over the air for device IDs is a new feature in 5G. Okay, so similarly, the issues of say rogue base stations or spoofing base stations, there's been some attention to it, although I think you will find academic and other literature saying there's still work to be done. So my basic point is that there are vectors which are in some broad sense positive. But then on the other hand, as was already pointed out, and as most of us believe, when you have a very complex system, and in 5G, as we well know, because of virtualization, particularly at the RAN, right, there are more pieces. More pieces mean more interfaces, and issues like slicing, which is sort of a notion of end-to-end resource allocation, of such complex pieces, which are all interacting. Well, on one hand, Dan, you mentioned that it is desirable to have customized security guarantees for different slices. Okay, but on the other hand, it means there are slices with perhaps poor security guarantees, and you may be able to infiltrate, introduce attacks with slices which are weaker, end-to-end security into slices which perhaps have stronger security, because at the physical and the RAN layers, resources are shared across slices. So again, like everything, there is change, and there's always change, and the balance of how this change plays out in particular scenarios, of course, needs deeper study. Let me sort of personalize. So again, there are other many broad sort of stroke themes. Let me point out one before I personalize this to my interest in security. And this is the fact that about the 5G supply chain. On one hand, we know that with creating more virtualized components, you will have more vendors. But again, on the other hand, when you have more vendors, you have to do more work to ensure that the components that they provide comply to the open standards, and that themselves conform to the security attributes that you want. So one can slice this question many ways. So I'll just sort of personalize it to my interest, which, as you mentioned correctly, more lie at the physical and the lower layers. And again, this is a point that Alex made in his slides. While in my program, let's say I'll pick an example. One of the most interesting technologies that have matured in 4G is MIMO. And there's a whole lot of work on what's called large scale or massive MIMO. But by and large, large scale and massive MIMO has only been deployed at sort of the mid bands. Okay, the maturation of massive MIMO at these very high channel bandwidths, which are offered by the millimeter waves, is TBD for various reasons. Okay, now one of those aspects is this abuts on is security, and this actually exemplifies, in my view, very well the trade-off that Alex was talking about. So we know for a very long time, for 50 years, that one way to trade performance and security is to do a spread spectrum, either direct sequence or frequency hopping. So if you give me very large bandwidths, right, and you allow me to only transmit over a short distance, I can drop the power and I can hide my signal, make it noise-like, right, whether through direct sequence or frequency hopping. Well, now we have an added degree of freedom. We have MIMO, and as you know, with MIMO, you form small pointy beams in principle. Okay, and we do that obviously for comms reasons, to either increase the range and or increase the rate for a given range. But we could also use that as actually it is done for mitigating jammers, interference, i.e., making the physical layer more secure. All right. So these are, just as an example, good use cases for how security at the physical and the RAN layers sort of abut the other various design imperatives of performance. And you can also, you can also look at, various other security attributes, not just sort of, anti-jam, LPI, LPD, but as you know, in say 5G or in NEG, you must have key distribution. So one very important security attribute is key authentication and key agreement, right? For which you need to distribute keys. And so again, how you use some of your communication resources in frequency, time, and space, for and trade it off, trade off your performance versus security. These are all open questions, and some of this already sort of Alex alluded to, and it's on, has been on NSF's longer term, agenda. And I expect that, some part of our programs, yours and mine, will also have to address this.
Absolutely. I think that's really, so one thing that's kind of emerging from all the panelists at this point is the importance of sort of the composition of security across different layers and techniques. And what's been thrown out there a little bit is, people have referred to network slices. So with the network slice, I could conceivably get my own sort of virtualized network to, give me a low latency network where Vincent might want a high bandwidth network, and we could both operate on the same underlying infrastructure. And of course, I guess I could request a slice that's secure. And let me use that as a nice little transition over to Dr. Wayne Full. So Wayne, you've been looking at this problem. You've even led some workshops on 5G security. I'll throw out one sort of, so please give your perspective, and I'll kind of add in there. Can't I just request a secure slice and I'm done, right? I mean, I should be good. So I'll pass it over to Wayne here. And so Wayne,
all right. Thanks, Dan. I wanted to start with, you had mentioned earlier when you introduced me about ARLIS. I thought I'd let people know what ARLIS is, because it's a relatively new organization. So it's ARLIS stands for the Applied Research Laboratory for Intelligence and Security. It's a new university-affiliated research center at the University of Maryland. And so really kind of the purpose there is to leverage the university resources towards government, primarily defense, intelligence, and security concerns. And so there's a lot of work in things like insider threats, supply chain vulnerability, and of course, 5G security. Yes, I guess to jump in, Dan, on your question of a secure slice, I think so. Slicing in general, I think, is one of the areas that's still largely a research topic, right? I think conceptually, there's a lot of great view graphs about it, and there have been some implementations of it, and you can even argue that there's been some slices implemented in 4G LTE networks. But adding the security piece into that and having security as a service, like Alex mentioned, I think is a lot easier said than actually done. One of the issues, particularly when you're looking at it from a defense perspective, is DoD is not only operating in the U.S., right, where you have good relationships with the network operators. They're going to have to operate overseas, where you have less control and less influence over the actions of those operators and certainly over their employees. And so how exactly do you specify what a secure slice means in those other environments as well? And how do you get the assurance that you're getting the kind of security that you're looking for in a bunch of different ways? I want to back up a little bit, and I thought I just mentioned a couple things that I think are new and interesting about the 5G vision as it's evolving. One is this concept of massive connectivity that we're having. Alex had a few examples there of where all the different new ways in which 5G is going to become a part of our lives. I wanted to add to that some of the utilities, things like food distribution systems, and as well as national security and the vision, right? All these things are greater enabled by some of the capabilities 5G is going to bring. And so it's going to be much more integrated into so much of what we do and how we live. A few folks have mentioned this move towards virtualization and softwareization. One of the clear benefits of that is that it enables greater diversity of suppliers, right? You have open interfaces, and we've got technologies like Open Radio Access Network or ORAN, as well as potentially new, you can have virtualized network functions. You could potentially have custom network function providers to put software into the network. And you can greater customize services. One of the concerns there, right, is the more capabilities and things you can do, the more ways things can go wrong. And the third thing that I think is really kind of interesting is this move towards enabling edge computing. And so you can kind of think in the limit of where what we were talking about, what 5G is and the capabilities that are coming with that, is moving towards really blurring the line between the computing and storage infrastructure and the communications infrastructure, right? And you can think of it as really just a highly distributed cloud computing and storage infrastructure, but where things move, right? As I move down the highway for some low latency application, I want potentially my storage and my computation to move with me. It's not necessarily going to be on my phone or in my car. It might be some resources at the edge, but that's going to travel along with me in the network as it goes. So it just increases the complexity of this. I'm going to hit a couple of the challenges. You mentioned security is optional. And Sumit mentioned the great move that they're adding over-the-air encryption, but that's not necessarily true for the IoT devices and some of the massive machine type communications devices, right? And one of the main reasons for that is to keep those devices low cost and low power so they can have long lifetime. So one of the needs out there, I think, are novel authentication encryption techniques that can operate for these very cheap, long-lasting devices. I think there's potentially some interesting work to be done, even novel concepts ID, not just have a traditional device ID, but we can think of other characteristics you can leverage to how you ID a component of your network. I think some of the interesting things about virtualization and software-defined networking, I mentioned customizing virtual network functions. I think one of the things that we want to be looking towards is how do we build some sort of situational awareness or monitoring and sensing inside the network. And I think there's some really exciting opportunities to leverage the new virtualized architecture to create more real-time network situational awareness. And one of the things I wanted to mention that I think is interesting, and I don't know, either how big of a problem it is or what the solutions are, but as we have so much more connected devices, whether it be wearables, phones, sensors around, a lot more RF streaming around us, there's just gonna be a lot more information out there in the network. Information about us, our activities, how we're accessing the network, where we're going. Even though device IDs are being encrypted over the air, there's still a lot more information out there for someone to mine. And is that a potential vulnerability? Is that something we should be thinking about how to protect? So those are my thoughts. Happy to talk more as the conversation continues.
Great. So I want to, so we'll come back to some questions and more discussion. I want to get Ehab in here as well. And so, as one thing that's also kind of emerging in either directly or in the background of all these, there's some issues of supply chain, and that's sort of a prominent issue in the in the press related to 5G. And perhaps I don't trust all of my network components, and that's that idea of having zero trust in my underlying components isn't entirely new to the security community by any means. Ehab, what's sort of your take on 5G security? And let me pass it over to you for some perspective on how you might look at this problem.
Okay, so thank you first, Dan, for the invitation. I shared my screen. I don't know if you see it. Do you see my screen that I shared?
We can see it. Right. We can see a PowerPoint document.
Yeah.
Yeah. Yep. Yeah.
Yep.
Okay.
There we go. Yep. Now it looks good.
Great. So this is a great panel. I think it's a great timing as well. I mean, I would like to take a different perspective from what has been said in the panel. I think has been a very rich information about what 5G can provide. From my perspective as a consumer, or from a DoD perspective, who are using 5G and leveraging existing public infrastructure of 5G, we would like to look at it from this angle and see how we can weigh benefit and risk here. And this is why I bring this to a key concept here: zero trust and zero control, and what does it mean from a user perspective. So just not to repeat what have been said by the panelists before, there are obviously huge opportunity here, but along with these opportunities, there will be also a huge risk and significant increase in the attack surface. And not only this, but also it's actually invisibility of what risk. There is a lot of unknown risk here. And this is very important. Unknown risk is the most dangerous thing in cybersecurity. This massive devices of obviously increase the potential of denial of service attack. We remember Mira and many other denial of service attack. It's you having this billions of devices that can access the network in less 1 millisecond at the edge, and they are easily hackable. It can be a nightmare. Also, the integration of different, all the way from the cloud to virtualization, increase the opportunities of misconfiguration. Actually, misconfiguration here is absolutely a good case study of a huge risk. Is misconfiguration in the policy side, configuration side, or even the orchestration side? Another one, which is about programmability and softwareization, software-driven networks. This is also increased the attack surface significantly because it gives the adversary actually a leeway to even control the entire network by controlling a controller or control maybe slices of the network and so on. So as you can see, this is a new dimensionality or a new of threat vectors and a new problems that raises from this. And we talked about slicing. Slicing is a perception. So from a user perspective, you think you have a slice, and you think you have an SLA that control the slice. But what's the guarantee that this actually slice is being configured end to end in the way that you desired and based on your requirements? With this, I think we have to remember that you are dealing with many multiple levels of components of the system, all the way from algorithms to protocol to virtual functions, access control, business configuration, security policies, and all of these needs to have a thorough verification at various time scale in order to understand that we are relying on a trustworthy network. So one of the things that I thought maybe to bring up to the picture here is the importance of provability and measurability for addressing these kind of challenges. So and I'm emphasizing the end-to-end provability because again, I'm looking at it from a user perspective. Of course, there might be some constraints or some requirements on the service provider to do probability and verification, but this is may not be reliable. So we need to have an end-to-end policy validation and enforcement based on SLA agreement and slicing agreement, and what's your expectation of the network performance and security. I've seen many of the reports talking about most of the telecom. They don't comply with the specification or the standard specification. So it's a black box. How you understand, and this raises a huge problem in testability and measurability. How you understand what kind of guarantees or what kind of implementation being provided on this kind of black boxes that we are dealing with. In addition to verifying resilience and so on, that might be sometimes important for the mission. In addition to this verifiability, also important to have an intelligent edge that can run a highly automated cyber defense from many different aspects to be not only reactive but also proactive, and automated threat intelligence and all of this automated response can be very, very valuable and also doable because of the edge capacity and accessibility. I think it's also worth a great investment of active cyber defense. From a user perspective, again, I would assume the worst. I would assume that SLA is not being conformant. I will assume the slicing has a problem. So what can I do from my perspective is to improve my posture where I can have more active defense that will do investigation response, maybe deterrence and deception to make the attack surface more obfuscated. So this brings us into what we call zero trust and zero control here. It is definitely a zero trust network because, or it should be assumed to be zero trust network because not only the increased attack surface, but also the invisibility of risk. And it's a zero control from my perspective because you have maybe no or limited access to the configurability of the core as well as the edge. So this is also determined from vendor to vendor or from provider to provider what kind of controllability you have in the edge, but definitely the core you don't. So it's not only you are losing trust, but you have a partial control. So from that perspective, what we can do as an end user, and DoD is an end user for some of this part of the network. So the zero trust architecture is very well defined, widely used, and is actually now it's very progressively deployed and has a very specific definition here, is to basically assume there's no trust and you always verify. And I think in this kind of situation, I think that makes a lot of sense. From my perspective as a user, I will be in a safe haven and peace of mind if I can have such an architecture because of such a unknown or invisible risk in this. And there are many other things that, authentication not equal authorization, the focus on the data access and data protection more than anything else. So this is just kind of an abstract model of how we apply this zero trust and zero control in such a complex network that can have misconfiguration, can have unknown attacks or novel attacks and things unexpected. So if we assume no trust, that means every time for every request, we have to verify and quantify. We have to verify and quantify, and then based on this, we decide. And the decision will be based on policies that's highly adaptive and dynamic and context aware. It depends on multiple parameters, decision making. And then we have to watch the enforcement, make sure this enforcement is done end to end. And if I don't have visibility to the core or to the edge, I can test this end-to-end enforcement and confirm that it is basically based on what I decide for. All of this also will be important to have a continuous monitoring and assessment that will help my verification and quantification. So if I apply something like this within my posture and with maybe the help or with no help with the provider, it can have a much better enhanced 5G network and inclusive networks that goes with 5G. So here's some of the high-level principles of how zero trust and zero control architecture can be adopted here. And some of these are pretty known standard practices in zero trust, and specifically the risk-aware tuning of least privileged policies. The policies are dynamic and should be dynamic based on context and based on many other external sources like threat intelligence sources. And access control is not anymore based on subject and object, but also based on the context and based on the implied risk. And this will be continuously evaluated. Multi-factor authentication may not be enough. So maybe we're going to have multi-factor, multi-level, and multi-channel authentication, because things can escalate in a way that may not. Micro-segmentation is very important for this. If it can be done in the edge, that will be great if you have provisioning to the edge. But also, it's important to make it a concept across the end-to-end perspective and how we can achieve this. Again, we talked about probability and measurability. I think this is very important, bringing science of security into the whole vision, along with 5G risk that we have. It would be cool to have something like this from an end-to-end, where the requirement and isolation, risk tolerance, and resilience are being fed as your parameters and requirements to the provider. And this will initiate the slicing creation and will instantiate what virtual function needed. And this will be easily verifiable than a vague and ambiguous SLA that may not actually be enforceable or verifiable. So something like this from a user end that will be highly controllable and verifiable will definitely change the way the 5G risk and minimize the risk of this. So I thought this perspective gives, like, there is a hope, but there's lots of work to do in order to adopt this new technology with this zero trust and zero control, and we still can manage the risk in a way that's acceptable for end users' perspective, especially DoD. Thank you. I think that's what I would like to share with the rest of the panelists.
Great. Thank you so much. So okay. So now, even though we're virtual, I think at this point, we want to move more. And so we've heard from all the panelists some very interesting perspectives. I think a lot of really cool stuff in there. But certainly for people attending, you're welcome to post questions into the chat. We'd be pointing at you and calling out a few people by name if we were here in person. Let me throw out kind of a disruptive question, which I think the panelists have answered, but let me see if we've convinced the audience and if anybody wants to contradict this, right? So we're talking about 5G security. Yeah, and we've touched on some concepts that anybody working in security is going to be very familiar with, right? Okay, it's security is optional. We may be trying to bolt security on rather than build it in. We've got a lot of different things to compose. So although this panel is 5G security, I'll ask in a role as a moderator, not necessarily that I believe this, but there's nothing new here in 5G security. It's simply security applied to 5G. Is it more than just saying security? I might even put Alex on the spot a little bit and say, so Alex, these seems like SATC proposals to me. Is this not just your standard SATC proposal?
Yeah, many of the aspects actually covered by SATC program, right? And even formal method in the field program that we launched like a couple of years ago and still going. Yeah, kind of trying to apply formal methods and reasoning about security. But what I feel, as I mentioned, that 5G in some way is a game changer. So kind of just by sheer kind of size of the system, right? And kind of we didn't see really before such an important societal system that kind of would be like of interest for many people to attack it. So as you mentioned, the need to kind of have security components and different elements and coordinate the security and compose those security functions across multiple layers. It's kind of for us as a game changer, right? So from we need really to design new science that we can handle such a large system, and definitely kind of integration with real world, right? So as mentioned here, right? So food distribution network, transportation, right? It's very hard to use existing tools that can be scalable enough and kind of comprehensive enough to deal with this, right? So this is some of the aspects of this. And also kind of traditionally security is kind of looking on attack vectors and threat models, right? So in this case, we need to go a little bit beyond that, right? So and also like Ehab alluded to that, some of the attacks cannot be foreseen, right? So it's kind of traditional SASE proposal, give me attack surface and give me like, you know, specific type attack and kind of do mitigation. I don't think it's really kind of promising approach here just because it's hard to know where attacks come from. So we need to kind of be able to protect against a broader class of attacks. So this is some of the, maybe like other panelists have some comments on this as well. So back to you.
Dan, hi, Sumit. Let me just amplify what Alex said, and also picking up on a theme that Wayne mentioned. Let me just again sort of personalize and give an example. You know, very often, you know, within the security paradigm, we keep going back to the previous Gs where humans are the end consumer, you know, which has been the dominant paradigm. And you know, one of the biggest game changers is, as I say, that we have to plan for networks in which humans are the relative minority. So, you know, and you have an increasing number of automatons, you know, who are both sources and consumers. Okay. As for comic relief, last night I was therefore going back to the time in which our Homo sapiens predecessors had, you know, many more predators to confront with. So maybe that's the dystopian future in which the attacks that we are talking about have little to do with us as producers and consumers, and have everything to do with those billions of devices, right? That you know, Wayne mentioned, which are mission critical. So the two key things is not only do you have non-human sources and consumers, the data that they are sending is actually mission critical. So you know, you have your your cars and your robots, and they're just sending a few bytes of a few packets. But that's extremely important for, you know, preventing some crash or some, you know, control, you know, information, right? So it is much less about, you know, identity protection than performance. So, you know, for the attacker, since it's mission critical, you know, I don't need to jam the channel. I just need to delay your packet. So therefore, the coupling between performance and security is even more tighter, you know, and so it goes back to something, and, you know, Wayne mentioned, you know, these billions of devices, they are poorly resourced, poorly, for reasons of mass production, etc. So I think we should look at 5G, you know, this game changer. The complexity comes from these non-human actors. And so, you know, as I said, we are maybe harking back to when our predecessors got eaten by various predators. and the future is likewise similar.
Yeah. So I would like to jump in with that's two examples that shows that actually 5G is not only game changing in technology, but this game changing in security, and it's a very nightmare scenario could be. Okay, for the first time now we're thinking of attacker. If it's in a traditional network, you know, can attack a route, attack a path, attack a router. But now attacker has the ability to take over the network by just hacking onto virtual function and maybe the controller. So this is a new attack vector completely that, you know, never existed in our traditional internet. I mean, unless if it's completely SDN. And this is, you know, was not, you know, in our provisioning. Then for the first time now, I'm thinking to protect my home, my network home from the actual network, okay? So previously it was the opposite, okay? So I was always, we are furious about how my home network can be vulnerable for the public network. It's kind of a reverse on how we think about security here. This is why I think it's just enforcing end-to-end security become much more than any time before. and it gives just a paradigm shift in how we have to think about it in order to counter this risk.
That's really good. Well, so then, all right, then let me take this the other direction, and maybe I'll ask either Wayne or Vincent to start on this one. So, okay, so you've convinced me that 5G security, there's something special here about 5G security. But as also one of the questions in the chat is there's a lot of complexity, there's a lot of composition. We're talking about everything from cloud computing to edge computing to MIMO and millimeter wave and network virtualization. The barrier to entry is too high, both in terms of testing and in terms of background that you need to get into this. How do you address the composability? How do we lower the barriers to entry to somebody who wants to play in this space? Yeah, Vincent, do you want to take a shot at that? Or?
Yeah. So definitely, I know and we've seen this both in the Federal Mobility Group and within Cisa, that the barrier of entry, for the research community, for other small businesses is hard, right? If you think about the standards, who plays actually in 3GPP, even in Addis, you're not getting the small players or just your researchers that you would traditionally get. Because it is a money business, right? It is people trying to get their methods and patents in certain ways so that there's royalties. It's very economical in that aspect. But as we move for this, accessibility, and there's a couple ways, and I'll defer to others too. But first off is if you look at the national strategy to secure 5G efforts, you look at the implementation plan drafts that are out there, you look at those that are on this panel, whether it's funding from anything in the 1.1 activities, you'll see a lot of research and development opportunities funded by DoD, OUSD, R&E, funded by NSF, funded by NIST, funded by DHS. There's a lot of opportunity there for researchers to really engage, and you can see the different calls of the National Spectrum Consortium, our broad agency announcements and other aspects there, right? So even small business innovation research. So I would say engage in that aspect is the first piece. And I know it's not the same thing as saying, oh, well, what about the 5G test range or the test assets that are out there? Because even if you look at, national laboratories and others, FFRDCs, that's not open to the public, right? That's not open to the research community. Says, please just let me go and use it. But if you're able to loop it in with these grants and other aspects, you get access through government programs. That's one method. Other methods, and I'll defer to Professor Wayne Full there, is if you think about access to open source information, right? As we move more to open RAN and software defined networks, there's less on the hardware proprietary specifics to more open standards and open access. So I'll stop there, and Wayne, if you'd like.
Yeah, thanks, Vincent, because you were just about to, I think, say everything that I would have said. So I would have just been left without anything. Yeah, I was going to say, I do think that while it's still pretty young, just the push for open interfaces does lower the bar a bit, right? It gives you more insight to what's going on inside. You can pick a smaller piece of the system if you've got a particularly new thing that you want to implement. You don't necessarily have to be able to build the whole thing in order to make a contribution. And I think it also makes it a bit easier for people like us to go in and try and test something, right? If you've got a clearer interface and you can understand what inside, how do I hook up, what should I be expecting going in and out of a particular interface, or how do I get in and out of that? It can help have more structured and more consistent tests that you can set up to understand what's going on in a system. And there also, I mean, there's increasingly more available implementations on software-defined radios, whether it be open source implementations of packet core, or at least source available that you can buy. And for me, particularly, just getting my hands around that and understanding what the implications are of having these network functions running in a virtualized containerized environment. And what does that mean in terms of how would I allocate resources to particular computing servers or things like that. I think those things are kind of lowering the bar to enable others to get in and make contributions.
So kind of picking up on that thread a little bit and adding in the question again, you know, anyone in the audience is welcome to throw questions into the chat on the ACSAC website there. But yeah, so following up on that piece and one of the other comments that was in there is, all right, so we got three GPP standards that are emerging that kind of sets a broad, you know, broad constraints on what's going on. We've got, you know, we've got what a particular commercial provider chooses to deploy. I could build a slice or something on top of that, but I've got, on the one hand, I'm constrained by what's in the standards, and as Dave Ballinson points out, the classic nice thing about standards is there's so many of them to pick from, but we've got standard complexity. I've got the operational ones, and we started to touch a little bit on some of the openness of this, and there's things like open radio access networks or open RANs and open cores. What does the panel have any sense of sort of where are those headed, or where would you predict? Is this a proprietary whatever big telco chooses to deploy, or how much of this is actually something that I can I can access from a smaller company or an edge system? I don't know if anybody wants to take a crack at that.
If I can start, so we had some conversation with SRS LTE, who is kind of doing open source. It's actually funded by DARPA and Open Air Interface. Kind of understand it's not there yet, right? And OAI has a lot of issues with stability and robustness, but SRS LTE, they seem to be very serious about testing and kind of getting it to industrial grade. So hopefully some of those alternatives, and some carriers already deployed some of this, right? But I'm not sure to which extent like a carrier will go to entire open source. And open source can have a lot of questions in security as well, right? You know that Apple smartphone is kind of a little bit more secure than Android, right? But sometimes closed ecosystem is actually kind of helping, right? So it's not like open source will solve all our problems. I'm just kind of sorry for provoking this. It's just a thought.
And I'll add just to note that really, even if open source is there and ready, right? And I know it isn't there yet, and we hope to be. And you look at the DoD 5G Ops program and others for DARPA and others, great efforts. But when you think about it, it's an economic issue, right? At the end of the day, you know, a lot of times, you know, why proprietary and why other things, or why even, you know, why did billions of dollars get put into the standards is because, you know, it's royalties that are being paid every time, you know, when we talk about what the deployment implementation. So as we look at open source and you think about how we do this, it's not just that it's open and you know, free to a certain extent, right? You think about how does that work, and how would the carriers, the OEMs, incorporate this, and you know, it's the sustainability, right? It's not just everything open source, therefore it's better. There's different schools of thought, whether closed, you know, or open is more secure. Arguably, both sides, I would say, right? And the thing to note, though, is that, you know, how is it sustainable? How is it, you know, enterprise or industrial grade? And specifically, how is this, you know, cost effective, right? I think that's some of the pieces that, you know, as with the research community, those that are in attendance, you know, how do we think about that as you approach a problem or you try to leverage some technology or develop a new technology? You have to really consider the cost factor.
Dan, hi, Sumit here. So just let me add a few things to what Alex and Vincent said. Since sort of in OUSD, I'm kind of tracking this. So point out that one of the disruptors for 5G is the notion of private or enterprise scale LTE. So, you know, we don't need the operators to adopt ORAN, okay? I mean, you're not looking for a service in which you can take your, you know, it suffices to have a solution in which the services that you want is within the perimeter of your campus or in your base, okay? And that is, as you've already seen, you know, that's a really emerging use case, you know, that's disrupting the industry. So whether that puts pressure on mobile operators to adopt open source RAN components for a wide area network, that's a different question. And obviously, the first order is that you are going to have, particularly, hopefully, manufacturing companies, what's called the old world physical manufacturing companies or agriculture, which hasn't been digitized, sort of adopt, 5G. Second, we do have 5G standalone, or we do have plans for 5G standalone. This is where enterprise LTE meets open source. And we are already, as you know, we have seen proposals where you're going to get these, new performers, the non-traditional MNO vendors, come and provide an enterprise scale network. That's one, okay? Now, when we say, open source, the most that is opened up, from, my interest, and I assume Alex is really the RAN, which was the closed piece where the hardware and the software was so coupled that, you had all of those, the IP, the licensing that Vincent talks about, right? So when you do have a market disruptions and opening up some pieces, value will move elsewhere. Okay, so you're going to have it doesn't mean that that you're shrinking the marketplace. You're simply rearranging it, because I think this is what Vincent was saying, is that value will move up the chain to perhaps the controller or the orchestrator, which is where you're going to see much more of competition, right? So it's not that that there are no proprietary elements, that there will be proprietary elements. It'll be elsewhere, even though you have open source components. Thanks.
And Dan, if I could just jump in with just two quick observations on this as well. One is one of the reasons for the genesis of the Open RAN push was really to increase the diversity of RAN suppliers, and the way Open RAN is going to be successful in that is really bringing down the cost, right? So that a lot of the focus up till now has been on reducing the cost of RAN solutions. And as we talked about earlier, that means that to a large extent, they've sidelined some of the security aspects, and they're really just focusing on how do we create something that's low cost. So that's, the security is something that, they understand it's important, but that's hasn't been worked on quite as much up till now. So that's the good and bad. The other thing that I think is also interesting about some of the 5G visions is 5G allows for non-3GPP access, right? And so you could potentially have like a Wi-Fi access network hooked into a 5G core and do some experiments that way. So you don't have to worry about some of the issues around license frequencies and things like that, or having your own, LTE or 5G RAN to do some 5G relevant core experimentations.
Great. I think that's a really good observation. So we have we're running up against our time limit here, and I believe the system may actually officially kick us off. So let me just go around real quick and say, if folks could give just any last closing remarks that you want to add in. Let's go sort of in reverse order. So Ehab, do you want to just add any last comments? We've got a minute and a half left.
Yeah, in short, I think it is, it's very important not to be technology driven at the time being, as we are exploiting and leveraging existing technology 5G. We have to be also conservative from a risk perspective and rearrange our own network. It's actually, this will be a call for restructuring our own home networks and the way we access the public network. And it's more urgent than any time before.
Great, thank you. Wayne, any closing remarks you'd like to add?
Yeah, I think I just wanted to build on some of the comments about how this vision is really increasing the complexity of the system in multiple dimensions, and I think we need to take a really systematic view of that, of how it builds out. I like the idea that Alex was talking about, trying to apply formal methods to some of these network systems and really understand what the implications are for interactions among the different components as we compose this larger thing. But really take we have to understand that it's going to be a much more complex system, and try and address that before it's too late.
Great, thanks. Sumit, any last remarks?
No, glad to be on the panel and hearing everybody else. Thanks.
All right, thank you so much. Alex, how about yourself?
Yeah, so just two quick comments, right? So one of them is security and resiliency, right? So we talked about this a little bit in the panel. So typically the reliability is different from security, but here for such a complex system, because system can crash even, like AWS server is not working, right? So we don't want 5G network to crash, right? There should be some built-in resilience in the network and kind of redundancy, right? So, and it's kind of helps for both security and reliability in such way. And kind of also want to emphasize those security architectures, right? So many people, it was one question asked there, right? What opportunity for research? So I kind of feel it's a lot of opportunity for research community, but it's very high barrier to entry, like just to sheer complexity of such systems, right? So we're trying to do it like through our Power platform, so we might deploy some 5G stack in there. I think DoD is doing a lot there as well. We also will try to work on releasing some data sets, which might be valuable, but I think community should organize and kind of think about how to attack this problem. It's kind of problem for community to solve. It cannot be solved by NSF alone, right? But it's kind of, it will be great if it attracts some interest from community. Back to you.
Excellent, thank you so much. And Vincent, you have the very last word.
Great. So just one thing, and it's related just because of the research community. As you look at doing 5G tests and security aspects of it, I would highly recommend if you look up the framework to conduct 5G testing. The group and I, the actual cross-federal government agencies, actually just published this out just last month. It is really geared to help people think through and a framework to really look through what's out there. What use case would it apply for a 5G test? It even has in 5.5.1 some security tests and aspects and metrics you can look at. But if you're looking to do any type of 5G testing, this framework document will help you develop a test plan. So just wanted to put that out there. You can look it up on cio.gov and find framework to conduct 5G testing.
Excellent. That's a highly recommended resource for anybody interested in following up with this in this field. So we are out of time. I would like to thank all the panelists for their great insights, and thank you audience for attending as well. And with that, we'll close this one, and we'll see you on the next virtual event. So thank you, everybody.
Thank you. Happy holidays.